This is what's on. They're trying to market. We had a buyer. We were trying to date somebody, and then we decided that we weren't going to take it to the next stage of engagement and married, so we broke up. That deal kind of fell through. So we are back. Back online doing the dating scene. Trying to find somebody that wants to buy it. It's the marketable piece of it, of course, is the waterfront. That's really what's the main attribute. It's got about 2,500 linear feet of bayou frontage. So the likely use of that 106-acre thing is some kind of terminaling, shipping, something that would take advantage of, the deep water access.
Okay.
Because Chevron has to keep that bayou dredged out, because that's how their petroleum product comes in. Their raw crude comes in on barge, and then they do what they do. They refine it, put it in gasoline, and all that kind of stuff.
Okay, so that's how this mess got started. Was whatever the deal with Mississippi Phosphates and Chevron?
Right. So as I think I was mentioning to you when we talked on the phone, it wasn't a coincidence they set up here, because what they needed to make sulfuric acid.
Right.
Again, the sulfuric acid was what was in the first step of the fertilizer production, and what that sulfuric acid does is digest the rock, and that makes phosphoric acid. And the phosphoric acid is mixed with ammonia, which makes an NPK fertilizer. It's that first step, the digestion process, that produces phosphoric acid as a product, or as an intermediary product. But as a waste in that first step is the gypsum. That's the stuff that we're having to deal with. That's the byproduct.
I gotcha.
I can show you some. This is it. DAP. That's what they made.
So this one?
Yep. And feel free to take it.
Interesting. And what's all this other stuff here?
This is gypsum. This is the byproduct, the stuff that we're having to cover. What is this stuff? That's just DAP. That's just fertilizer. This is ground rock. So this would be, when they say ground rock, this is the unground phosphate rock. This is the stuff they were bringing in.
Uh-huh. Okay.
Oh, that's the ore. That's just the,
Okay.
And here's the ground powderized rock, and it's, and then they would digest that with sulfuric acid.
Gotcha.
Again, we're here. This is that west stack. This was the original gypsum disposal area, 270 some acres. This was plopped right in the middle of the bayou. This is Bayou Gassat right here. There's zero engineering in this guy. This was closed up by the company.
Okay.
In the early 2000s, and then they opened up this one as an expansion. This has no leachate collection, no engineering at all. They did cover this up with liner and dirt. It does bleed leachate. You see this little milky white ditch that's all around here? That's called the DAP ditch, for whatever reason. But that actually is a big moat around the west stack that actually collects leachate. So we actually have to keep it pumped down, or that leachate would overtop and float in the bayou, and that would be a bad thing. So we have to keep the water level of that DAP ditch pumped down, so it does not overtop the berms and get into the bayou. So this is a source of bad water that we have to handle.
Right, and how many, because I was reading, I think on the fact sheet that EPA has something like 1 million gallons.
We're running, this system, then we have a lime treatment system here. We have two ways to treat water here. We have a primary mechanical water treatment plant, which we inherited from the company. That's how they did it.
Okay.
And so all we're doing is we're pulling water off this DAP ditch. It goes into our treatment system, and we hit it with lime. And lime neutralizes the pH, takes it from a pH of about 3, takes that pH up to about 7 or 8, that's the discharge criteria, right? That's neutral. pH of the scale is 0 to 14. And then that lime slurry is stuff that we have to deal with. And then we pump that lime slurry from the mechanical plant out here into a series of geotubes, and I'll show you those. And we hit that lime slurry with additional polymer, and that lime slurry then is being captured in these big bags, and then we're going to ultimately cover those in place. And then that water is partially treated. It comes out into this effluent leg, and then we send water back across, mix it with mechanical treatment water, and then we discharge it to the bayou right here.
Okay.
Yeah.
So it's all safe for fishes and
Yeah.
oysters
Oh yeah,
and
we
all
treat.
that
I mean,
stuff.
believe me, we monitor.
Yeah.
Oh, we're looking at we take samples of that 3 times a day.
Yeah.
Yeah.
Yeah. Okay.
First in the morning, mid around lunch, and then it's closing time. So I mean, and we run that water treatment plant 24 hours a day.
Okay.
2 shifts, 12-hour shifts. This is what we're trying to close. So as I mentioned to you on the phone a couple weeks ago, we're in the rainwater treatment business here.
Right.
And it's a bad business. You want to get out of the rainwater treatment business. It's expensive. So
Yep.
what happens is this, because of this large footprint of acid generating material, clean rainwater falls on that, becomes contaminated, and then 1 inch of rainfall that falls on that stack creates 9 million gallons of water that we have to subsequently hold on to, trap it, and then treat it and discharge it. And I got to get out of that business. It's terrible business.
Yeah.
So what I want to do is, what we're trying to do, you'll see this right now, is we're putting a cover material on this to eliminate that contact. Eliminate rainwater contact with acid generating material.
So what is there? So you're just going to cap it essentially.
Yeah, with that, I'll show you what we're going to cap it. We're going to cover what we're actually. Hey, Mark, can I borrow your truck later to go take these guys for a drive?
Sure.
Cool.
Absolutely.
Because I don't want to take them out in my kayak. That little truck. It's not going to fit everybody. So the cover material is a really 3-part system. This is the base liner. This is 50 millimeters or 50 mils thick. It means it's 50 1/1000th of an inch thick. 1 mil is 1/1000th of an inch. And so the bottom of this is, it's called super grip net. The bottom has got these little, pokey things, and that helps kind of anchor it in the subgrade. So that's the bottom. This goes right on top of gypsum.
Okay.
And we're putting this down right now. You'll see this. We got about 5 acres of this down right now.
Okay.
And this is a drainage layer that helps, as water, this is actually going to shed the water. And then on top of this is not my lunch. This is the actual, the closure turf stuff itself. And this is a fabric. We call it turf because it's our carpet, because it really is. This is manufactured by Shaw Industries, the same people that make carpet.
Okay.
Manufactured in North Georgia, Dahlonega. And so this fabric material, this is like it's like a turf that you would see on any athletic field. It's not all that different,
Okay.
And so that's got these fibers in it, and then you put it in on top of the liner, and then you backfill it with this sand, about 1 inch of sand. And this sand is what keeps it anchored. It keeps it, this is ballast material to keep it from blowing away in the hurricane. This is the weight that keeps everything down. And that's the cap system. That's it. Pretty simple stuff. Now what this done, I think I mentioned that, this replaces, it's a rather innovative cover. There's about, 2,000 acres of this down in the United States. One company makes it. They're out of Alpharetta, Georgia, called Watershed Geosynthetics. So Watershed Geo makes this stuff. This replaces the old traditional way of capping landfills. We've been capping landfills in the United States for probably 100 years, And the old way of capping landfills is typically some kind of liner material, the various thicknesses. Then to protect that liner from UV degradation, sunlight, and all the other elements of the Mother Earth, we typically would put 2 feet of dirt on top of this, right? And then you grass it, then you have to mow it. That's how that landfill was closed out. The West was closed out with this, the old traditional way. Liner, 2 foot of dirt, grass it, mow it, call it good. In the case of the dirt, I think I mentioned this to you when we were talking earlier, we did kind of what's called a value engineering study. We compared the traditional way of doing business, which would be liner and 1.2 million cubic yards of fill material, 43,000 trucks to haul that dirt in, versus a closure turf approach. And this newer innovative cap design saves about $6 million in capital costs and operational and maintenance costs. And then some of the other added benefits of it is that you don't have to mow it, you don't have to water it, you don't have to fertilize it, okay? And we got, some of the other things we were able to save is that, we get some green remediation bonus points because we eliminated 43,000 truck trips on the area roads. So our carbon footprint is reduced by using this material as well. And we think we can get it down faster. When you're trying to put dirt on a landfill, your cover soil, and it rains, you can't spread mud, right? You have to usually wait a couple days to dry out your cover material. So that's 2 days you can't put cover down. In this case, since we're not using dirt as cover material, if it rains, the very next day, that gypsum dries pretty quick. Very next day, we can be, we don't lose out on rain days. We can just put that down right away. So, you want to go for a drive?
Let's do it.
All right. Howdy, Craig Zeller, EPA. Yep, you Jim.
Yep.
This is huge
Smell that? That's sulfur. Yeah.
My past is coming in. I didn't know what it was. I just kept riding past.
Yeah, this is it. This is our ugly baby. Step on the bottom. This is this super exciting part. You roll this out, and it's basically like big rolls of paper towels, and then each one of these gets seamed. It's called extruded welded. See how this? You melt this, and it's a double seam extruded weld. So what we're gonna do is shed clean rainwater off this, shoot it through those two 24-inch pipes into that clean stormwater ditch, and that what we've done is just eliminate the need to treat that water.
Gotcha.
Keep clean rainwater clean. That's the idea. Eliminate the contact. We're north of $40 million already on water treatment. This first phase of closure, which is about 1/3 of it's like $15 million. So we're 40 plus another 15. We're $55 million into this, and we're really just kind of getting started.
Okay.
So on the company's watch, they had 2 big catastrophic releases. And I can't remember the exact dates of them. I got them written down, of course, in my PowerPoint slides and stuff. But one release was to Grand Bay, and that was bad. That was $1 million in fines, Clean Water Act. It was very expensive, and it wiped out several hundred acres of habitat over there. And then one time they lost a release to the bayou, and that was the one that resulted in 47,000 dead fish and all that kind of stuff. Again, now these are the drainage bridges. This is, I don't know if you can see it, the two 24-inch pipes are right there. That's the receiving water ditch. It doesn't have any water in it right now because it's so dry. Yeah. But that's the clean water ditch that's going to take this stuff to the bayou. Look at that ditch. There, that's leachate bubbling. See that leachate bubbling out of that pipe? Mm-hmm. At the third phase of this, or what I call phase 1C, we've got to latch onto that. I want to isolate. That's the water I want to treat, and I have to treat. But that's leachate water. It's probably bubbling about 20 to 30,000 gallons a day. That's the water that we are going to have to treat that water forever. But the good news is it's 20,000 gallons a day as opposed to 2 to 4 million gallons a day. That's progress. That makes engineers really freaking happy right there. It's real simple. It's black plastic and all that, 50 mil liner, but man, you don't know how long we've been working to get to that stage. The cleanup decision on this was written April of 18. Then we did that value engineering study to determine what kind of cover system was going. That value engineering study kind of went on from April to June. Then we had to, of 18, then we had to do the design quickly to get the 6-to-1 slopes and all those, the concepts here. That was all the engineering plans and all that stuff. And then we issued the first contract on that in November of 18. So we've been working on that slope for roughly a year. So it's taken us, what is that, about 18 months from conceptual design to actually putting liner on the slope, which, as James will attest, in the world of Superfund, are pretty damn fast. Yeah. Again, there's a sense of urgency here. Every day is about $40,000 to $50,000.